Okay, this video is about the neuron. Now we have, I guess 100 billion, I haven't counted lately, but about 100 billion neurons in the brain. We have a little component that's called the hindbrain, or the little brain, or the cerebellum, and the majority of these neurons, at least, I shouldn't say the majority, but at least 50%, and counts vary, folks. Not quite an exact science yet. We may think that this is an exact science, but this is not quite an exact science. And as far as the study of the brain is concerned, we know a lot about the brain. And we can be thankful, that individuals have went ahead and worked in the area of the brain. It's unfortunate that some individuals had to suffer because of this. But nonetheless, it gives us a better understanding of the brain. So what we're going to be looking at now, we're going to be looking at neurons. Remember how many neurons we have? Around 100 billion. 100 billion. That's quite a bunch. But I'm going to go through some very, very basic aspects of the neuron. First of all, and this probably isn't the greatest drawing in the world, but we have the brain, and we have the bumps, and these bumps and so forth are cortex. And if we took the brain, and if we spread it out on a flat surface, the cortex, which means bark, because it's rough like a tree. But if we spread this out, it would probably be about the size of a newspaper. This here being the front of the brain, this here being the top of the brain, this here being the back of the brain, and this here being the bottom of the brain, and we will be talking about the old brain. Now, around 100 billion neurons, remember we talked about 100 billion neurons are needed to, not needed, but necessarily make up the brain. And that's only about 10%. The rest are glial cells. Now back here, we talked about the hindbrain, or we talked about the cerebellum. Now of the 100 billion, there's about 50% are contained in the cerebellum. The cerebellum helps us with our balance. So this is something that is very important. Cerebellum, what I'm doing now is kind of a cerebellum activity. It's kind of a hands-on activity. And so I believe that realizing this is important, because this is the way we begin to learn. All right, now, breaking this down just a little bit further, I'm going to throw in another term here. It's the B, blood, brain, barrier. Now maybe this is too early to introduce this, but I'm going to, because we're going to be talking about it from time to time. The blood, brain, barrier. Now what this is some type of a protective coating around the brain that will only allow certain elements in, certain chemicals into the brain. Now, okay, with me on this. All right, now, so it's kind of like a net. And if the objects are too large, they can't get in. And it only just allows specific aspects in. Now, stress, watch this, stress will enlarge these openings here so more material can get in to the brain and possibly hijack the brain or disrupt the function of the brain. These are just some of the aspects that I wanted you to see on this. So we have the brain here. We have the cortex, which means bark. There's about 100 billion neurons. That's 10%. The other 90% is glial cells. And we have the blood-brain barrier. So now we're going to take a look at a neuron. There's one particular aspect of the neuron that I really, really want you to remember. Okay, we have the neuron, and right here, these receive the messages. These are called the dendrites. Are you with me? Okay, these are the dendrites. Then we have here the cell body, which organizes the messages. And then we have a long aspect here, and the length of this, actually it can be quite long at times. And it looks like this. And this here is called the axon. Okay, hang in there with me now. Now, what happens is, messages come in here. Chemical messages come in here. There are little receptacle sites, and we're going to be talking about this a little bit more later on. There are little receptacle sites. Then these messages go to the cell body. Then the cell body takes them to the axon, and we have a myelinated axon here, and we have these nodes of Renway right here. And what happens here is that this here is an electrical Okay. Now, as I was saying then, there was a slight interruption here. But as I was saying, this here is an electrical pump that puts positive and negative charges together. So the message comes in here, goes into the cell body, and I apologize for that little blurb, but I couldn't help it. And we're going to just continue on. So we have the messages coming in here, going into the cell body, and then this down here, this is used here, these myelinated, these are nodes right here, nodes of Renway, and we have pumps in here that electrically pump the messages down to the end here, and then when it gets to the end here, there are some more sites here, and these are chemical sites. This isn't the best, but it's going to do for right now. Okay, these are chemical sites down here. And so then these chemicals here go to another dendrite. And so then the chain continues. All right. So I've been taught, and the classes that I've taken, that the messages come in here, and this is one of the main aspects that I want to look at, and then we're going to continue. But I think that this is very, very important. Messages come in here. They go into the cell body. They go down the axon. And then they go through here, these terminal buds, and then across the synapse to the dendrite again, and then the messages continue on. Now, here is aspect that I really feel as though is important. And the aspect is this, is that new information, and I'm going to emphasize that this is new information. This is the same as individuals in the Olympics when they practice their different sport areas. New information could be material that we have just learned. New information could be driving an automobile. When we drive an automobile for the first time, that is new information. Musicians experience something new. Students experience something new. So this is what is interesting, and this is as far as we're going to go in this video. The messages go down this way. The messages go down this way. I emphasize this because this is what I have been led to believe. Now, I don't think anybody was trying to say any falsehood. But what happens with new information is The information comes down here, goes in the axon, and then with new information, while we sleep, the new information seems to go back up towards the cell body and is processed longer here. Now remember, I was taught that the messages start up here with the dendrite, cell body, axon, down here to the terminal buds, to the next dendrite. And in most cases that is true. So this is something that is just an aspect, not something, but this is an aspect that has just recently been learned. With new, I have to emphasize, new information, it seems to reverse and go back up. And it's almost like a rehearsal. So it is better understood in these neurons. Now this happens when we sleep. And so for the most part, it takes sleep for this to happen. And this is one of the important things about sleep, because I have heard the comment made over and over again, do we really need sleep? So what I want to get you here on this, just a review, we have the brain, 100 billion. We have the blood-brain barrier that just allows certain things into the brain. We'll be talking about this a little bit later on. Then we have the neuron. This is the neuron right here. Messages traveling this way, except for, and I'm going to put the new information. Now, this new information actually changes the shape of our brain. And this is an important aspect that we should remember. And this is why it is so important in sports, as a student, as a musician, whatever activity, occupation you are in, when we have new information, when we sleep, this tends to reverse. Okay, this concludes us for this video. I hope that this information is helpful. That's why I'm presenting. And so if you have any questions, be sure to go ahead and send me an email, because we want to go through this together. We have a lot of information to learn in knowing how the brain relates not only to everyday behavior, but how we sleep, but also abnormal behavior. So until the next video, you folks have a good day. I've enjoyed visiting with you.